Hey guys, this is Mr. Balin coming to you with a lesson on how to find the distance between 2 points on a coordinate plane. All right, so first we're going to start off with a coordinate plane. And in geometry, throughout the entire school year here, you're going to have to tell me how far apart 2 points on the plane are. So if I give you 2 points, something like this, and let's say that this has the coordinates of like 6, 2, and this has coordinates of like 6, 10, something like that, right? Those 2 points are perfectly vertical with each other. Now, I didn't draw the little tick marks or anything like that, but if I wanted to know how long is a line that connects those 2 points, how would I find it? Well, you actually could just count it. Like if you're starting at a height of 2, right? Wouldn't that be 6, 2? And you go all the way up to a height of 10, how far have you gone from 2 to 10? Well, that's a distance of 8. Remember, to get the distance between two things, you subtract them. 10 minus 2 tells me we've gone 8 units. So if a line is perfectly vertical, you can just count how far apart it is. What about if a line is perfectly horizontal? So similar idea. Let's say I have a spot here. Let's say that this is like 3, and we're going to go all the way to 12. And let's say we have a coordinate here at 3, 3. And then over here we have a coordinate at like 12, 3. So again, I want to know how far apart the 2 points are. Well, if they're perfectly horizontal, you can just count the points. How far have you moved horizontally if you've gone from 3 to 12? You've traveled 9 units. So this would have a length of 9 units. 12 minus 3 is 9. So vertical movement, horizontal movement. How do we know that this is perfectly vertical? Because my drawing's not that good. It doesn't look like a horizontal line. But I'm telling you that it has a height of 3 in both situations. So even though I didn't draw it perfectly, I know that it has a height of 3 both times. So I know it's staying perfectly flat. So what if it's not vertical and it's not horizontal? That's where it starts getting much trickier. And we're going to get really good at this. But let's say we have 2 coordinates. Got this guy here and this guy there. Actually, let's move them over a little bit. Put them there and there. Okay. So let's say that this one is, I don't know, over 3 and up 4. So it has the coordinates of 3, 4. And then this guy is maybe over 10 and up 9. So let's say that this guy has coordinates of 10, 9. So we're traveling from 3, 4 to 10, 9. And if I were to connect those, they would not be vertical or horizontal. So my question would be is how long is that black line segment that connects the 2 points? Yeah, this gets a little bit tricky. But we're going to use my personal favorite thing. What am I drawing here, guys? It's the first love of my life. It's called a right triangle. How is a right triangle going to help me figure out the distance between those 2 points? Well, can we count, like we were doing a second ago, could we count the horizontal distance? Well, yes. I'm going to call this x1. I'm going to call this x2. How far apart are the x's? That's the horizontal distance of our right triangle. That's like the base of our right triangle. I know how far apart that is. I know that it would, like if I drag it down here, that this would be like 10, 3 down here. I know that. Or sorry, 10, 4 would be a height of 4. The x's start at 3 and end at 10. That means we've traveled 7 units horizontally. How about vertically? Let me get a different color in here real quick. So if I start at 3 and I go to 10, I've traveled 7 units. What about vertically? What height am I starting at? What is my starting height? 3, 4. I'm going to call this y1 and this y2. How far is it from y1, 4, to y2, 9? If I start at 4 and go to 9, I've traveled 5 units. So in this situation, I have a right triangle, which we've learned before we can use Pythagorean theorem for. So the Pythagorean theorem says that a squared plus b squared equals c squared. We're going to change that up just a little bit. We're going to call this delta x. We're going to call this delta y. Delta just means the change. You might have seen it in your science classes a little bit. The change in x is how much did the x's change. So we're actually going to do delta x squared plus delta y squared. And instead of calling this c, we're going to call this d for distance. Because that's the end goal. It's called distance. We want to know how far it is, the distance. So we're going to call it d squared. So it's the exact same formula. We're just changing what we call a few things. Delta x squared is 7 squared. Delta y squared is 5 squared. And that is going to equal d squared, which we don't know. 7 squared is 49. 5 squared is 25 equals d squared. And then to wrap this up, actually we need to combine the 49 and 25. It'd be 49, 69, be 74 equals d squared. And then to undo that square, we're going to do the square root of both sides. For now, we can just type it in the calculator. Maybe you already know if this simplifies or not. But if you don't know, you type in the square root of 74, and it's already simplified. So the distance is just the square root of 74. You will have to round sometimes. If you do, we're going to round to the nearest thousandths. You could get a pretty good educated guess, though, because you know that the square root of 64 is 8. We know that the square root of 81 is 9. We're a little bit closer to 81 than we are 64, so I know it's going to be closer to 9 than it is to 8. That's just a rough guess, but you type it in, you change it to a decimal, and that's going to be 8.602. And we're going to round to the nearest thousandths pretty often in here. Both of these are good. Square root of 74 is a little bit better. That's the exact answer. 8.602 is the rounded answer. So let's talk about that process again. We have our two coordinates, 3, 4, and 10, 9. 3, 4, and 10, 9. And what did we do? We figured out how far apart are the x's. 3 to 10 was a distance of 7. We figured out how far apart are the y's. 4 to 9 was a distance of 5. And that was like my base and my height of a right triangle. All right, we're going to get a little bit faster. We can't be that slow. We can get really good at this. Really good at this. So let's just give a couple coordinates. I'm just making this stuff up. But -2, 6, and 1, 3. Something like that. And I want to know how far apart the 2 points are. So we're going to apply what we just talked about. So we're going to find delta x. And let's think about this. We can just draw a number line if we want. Delta x, it's starting, we have -2 and we have 1. So think about those like on a number line. How far do you travel to go from -2 to 1? Well, that distance from -2 to 1 is 3. So delta x equals 3 for this problem. How about delta y? The y values, draw a little number line. We can even do it vertical if you want, because y is technically vertical. We have a 3 and we have a 6. So I'm looking at the y values of 3 and 6. How far is it from 3 to 6? Well, that is actually also 3. So for this particular problem, we know that 3 squared plus 3 squared has to equal the distance squared. That's 9 plus 9 has to equal the distance squared, so 18 equals the distance squared. What do we do to undo that square? We do the square root of both sides, so the distance equals the square root of 18, which if you simplify that is going to be 3 root 2. So we're figuring out how far apart are the x's, square it. How far apart are the y's, square it. I want us to get pretty quick at this though, so I'm gonna show you a few more examples, then we'll be done here, but I want to show you how to go a little bit faster. So let's say we have 2, 4 and -3, 1. Just making stuff up. The goal is for you to eventually be able to look at this and be like, okay, 2 to -3, that's a distance of 5, I'm going to square it. 4 to 1, that's a distance of 3, I'm going to square it, and I know I'm going to take the square root of that answer. That's how quickly I want you to eventually get. We're going to be doing this throughout the year. There'll be problems where you have to do this 4 or 5 times on one question. So we can't spend a lot of time doing it. I know we just learned it. I don't expect you to be a master of it right this second, but I eventually want you to get where you're doing it pretty quick. So, and actually you can just type this straight into your calculator for now. We're going to simplify this stuff by hand later, but it comes out to the square root of 34. So the goal would be able to get this down in about 8 seconds. Takes a little bit of practice, but that would be the goal. All right, I'm going to do one more just so we can take a look at it. Let's say we have 7, I'll do -7, -5, -10, 1. So I want delta x, delta squared. I know that it's going to be the distance between the x's. Well, how far is it from -7 and -10? They're both negative, so it's only going to be a distance of 3. -5 to 1, it's going to be a distance of 6. That's going to be 9 plus 36. That's going to be the square root of 45. Square root of 45 does simplify. That would be 3 root 5. And that's the answer I'd be looking for. Now, if the question tells you to round, you do need to round. You need to pay attention to what the instructions tell you. But that's it, guys. That's how you find the distance between 2 points. Let's get really good at this.